Hi, can everyone hear me?
Yes.
Super. Can you hear me now? Can everyone hear me now?
Yeah.
Awesome. So, hi, my name is Rudraksh. Sometimes people call me Rudi, so I roll with that usually. And I've helped co-found this startup called Math Harbor, where we're trying to build a cloud-based hub for computational mathematics and statistics and a lot of other different things. And part of our work is to find the perfect language, so to speak, for scientific computing. And one fine day, I stumbled upon JavaScript as a possible candidate. So, when the whole Haskell thing came up, I thought, why not go into it deeper, share what we've done, and maybe somebody will run along and pick up on it. So today, we're basically going to talk about using JavaScript for mathematical and scientific computing. We're going to talk about the pitfalls, the advantages, and also some of the work I've been doing, which, like I said, if it appeals to someone, you chaps can take it further. Right, so when I say scientific computing, the first couple of languages that jump to your mind, Python or MATLAB. I hate MATLAB, by the way, so let's not go there. Julia. They're great languages. I mean, people have been using these languages across academia, across research, across corporations for a lot of years now. And there's a very good ecosystem around them. So, what's wrong with them? Nothing. They're great languages, but they have issues. Right. JavaScript is inherently event-driven. It's asynchronous, which Python, Julia, and R are not. I'm not saying Python is not event-driven or asynchronous. You've got some good libraries to make your code asynchronous out there. But the language itself is inherently not supported for that. Julia, not asynchronous. R, let's not even go there. But JavaScript is. Now, the other problem with the existing languages is that they're server-side languages. They work on servers. You can't really run them in browsers, although I believe there's this library called Python which allows you to run Python inside your browser. But it's just not the same. I mean, there's no interaction between the client and the server. The languages are not the same. And when the languages are not the same, I mean, I'm sure all of you would agree, things are just not comfortable. The third reason that I believe is really important is that unlike Python or Julia, JavaScript bridges object-oriented programming and functional programming in an amazing manner. Now, Python was originally conceived as an object-oriented language, and as Python 2.x came along, Cairo von Rossum decided to include functional programming in it as well. So it does have decent support, but not as great as a language like Clojure or F# or Haskell. Julia, latest, really new language from MIT's Technical Computing Lab, and it's meant just for technical computing. It tries to, build up on those faults, and it tries to bridge both of these worlds. But again, I'm afraid they've not really done that great a job, because Julia then tends to go more into the functional side of things. And a lot of us, when we start out programming, we don't really get into functional programming. We start with imperative or object-oriented programming. But in my world, in the world of mathematics, it's functional programming that rules, because at the end of the day, everything's a function. Everything's a mathematical function. On the other hand, JavaScript, bang on amazing. Right. So I think the biggest question that I had when I started off, and that I'm sure a lot of you are coming up with, is that Python's got a great ecosystem, Julia's got a great ecosystem. I mean, a lot of community-driven libraries out there for doing anything. So does JavaScript have the same thing? Does it even have the tools that you need to get the job done? Yes and no. Now, what you'll find in JavaScript is a lot of small different libraries for basic mathematical computing. So I'll name a few, and I'll also do a couple of very, very small demos to show you what the possibilities are like. For instance, there's this amazing JavaScript library called numerical JavaScript. What it essentially allows you to do is linear algebra, differential equations, mathematical optimization. That's really important in operations research and in A/B testing too, if I'm not mistaken. So it allows you to do that on the client inside of a browser session or on the server using the V8 engine or using Node. And with a bit of work, you can even get it to run on microcontrollers or other robotic devices, which we'll talk about later. Then there's another library called set, which is a really nifty tool for set theory, functional set theory. So that comes really handy when you're trying to get into discrete mathematics. Then a couple of other libraries, something called JMath, which is again for linear algebra. But the problem is that these libraries are very, how should I put it, theoretical. You can't really use them a lot for practical situations. Unlike, how many of you here are familiar with libraries like NumPy or SciPy? Exactly. So, those libraries are vast. You can use them in a lot of different scenarios, and they come with a lot of inbuilt functions, which make your lives easier. And unfortunately, these libraries are not at that level. And how do we address that problem? We'll come to that in a bit. So right now comes the time for demos. So we're going to check out small code examples that I've written for 4 different libraries. So one's called numbers.js, which is again for very basic calculus, differential calculus. Then numeric JavaScript, which I mentioned earlier. Then we've got something called clusterfuck, excuse the language, which is used for clustering, very important for machine learning. And you've got something called brain.js, which is actually a really nifty library for convolutional deep learning, neural networks inside JavaScript. So here we go. I don't quite think any of you can read what I'm writing in the terminal, right? Then we have the MacBook experts up here too. In case the font size
Command plus.
Command plus. Is that any better?
We reduce the resolution.
Change the theme.
Change the resolution also.
Theme.
I think everybody can read what I've written there.
Zoom in for
Slightly more
full
full
screen.
now.
Yeah.
Super. So please give me a second while I log into my cluster. So let's get started with numbers and trace first. Sure. Absolutely.
Just try to mic open so you can just keep it here so that you don't have to do it.
Okay. Hello. Nothing. Can you hear me now?
Yeah.
Awesome. It's okay, I'll do it. Alright, try it. Right, so let me quickly show you a little bit of code that I wrote for manipulating basic matrices. Yeah, I don't think that works. Alright, I think that makes more sense. So, as you can see, plain old JavaScript. All that I've done is include this library that was available on npm that you can then install using npm install numbers.js. As you can see, it's pure JavaScript. There's no great shakes to it. You use the same syntax. All you have to do is make sure that you're using the library in the right manner. The point that I'm trying to drive at here is that I'm assuming most of you here are web programmers. You write code for the web. Am I correct in assuming that? Super. Well, the good news is that you've got decent support for actually building technical computing into your web apps, either on the front end or on the back end. Could be anything. It could be basic matrix algebra, which might be useful for, say, calculating routes between 2 different geospatial points. It could be neural networks to analyze colors, or as a friend of mine did, he tried to compare cats, and his neural network succeeded in differentiating between cats on the client side. And that's saying a lot, because being a human being, I cannot differentiate between two cats. So as you can see, just doing simple matrix addition, matrix subtraction. So these libraries are very well documented. I'll share my repository link with you later, so you can easily go in there, fork it, play with it. And like I said, I've been blogging about them on my blog, so you can go check that stuff out too. So let's try running this. And voila, it works like a charm. In fact, curious note, one of the things that I noticed with this particular library is that when you want to subtract one matrix from another, you have to use the addition function. And the reason for that is, for some reason, they forgot to implement the subtract function. So when you have to subtract a matrix from another one, you simply have to invert the second matrix. You know how it goes. 2 plus 2 is 4, but 2 plus minus 2 is what? 0, right? So that's how it works. So that is one of the key pitfalls that using JavaScript in these situations entails. There's not a lot of support. In fact, this particular library has been defunct for the last 2 years. It's now that I'm trying to pick up on it and trying to work on it. But that's another problem that we're facing. A lot of people lose interest when they're building these libraries, and they just lie around. Now let's check out another library. As you can see, not advisable to go to mine and type. Alright, this looks better. So let's check out the optimization example. So in mathematical optimization is all about finding the most optimal way to do a particular thing. Could be anything. Could be finding optimal fuel routes for a particular airline. It could be finding, figuring out what your marketing spend should be if you're, investing on different marketing channels, online, offline, Facebook, Twitter, whatever. So there are two different methods, the two different categories of optimization. One is constrained optimization, where you specify a list of constraints. For instance, in the marketing example that I mentioned earlier, let's say you have a budget of $1,000 and you don't want to spend all of it in one channel. So that's constraint number one. Constraint number two could be you don't want to spend more than $200 on Facebook or on social media. Constraint number three might be you're willing to overspend when it comes to, say, Google AdWords. So these are constraints that you define, and then the algorithm tries to figure out the best, the point of best fit between all those constraints. So you might have studied it under the name of linear programming back in school or college. At this level, it's called optimization. So over here, very basic code that I've done, where I've tried to optimize two different square law functions and find the most optimal fit between them. So this particular code is used a lot for airlines. So when Indigo is trying to figure out how much to charge you for a flight from Delhi to Bombay, this is the kind of algorithm they would use to figure out how if you notice when you book a flight ticket, there's a fuel surcharge that they charge you. So this is the algorithm that helps them figure out how much should they charge you for fuel, for the airline fuel. Now just imagine if this were running in the browser. Now that would be awesome. And it can run in the browser. But okay, again, there are benchmark issues, there are timing issues, and I'll come to those in a bit. Now let's check out the clustering example. Alright, so as I mentioned, clustering. it's basically an aspect of machine learning where you have seemingly disparate data points, and you basically cluster them. So a clustering algorithm tries to figure out trends and patterns between those disparate data points, and it tries to draw a line of best fit, which again comes under optimization. So one of the biggest applications of clustering is in color analysis or image analysis. How to recognize colors, how to teach a computer to recognize colors. With JavaScript, and more specifically with this particular library, you can essentially teach Google Chrome or Firefox, or even Safari, to recognize colors. Right. So what I did was very basic example, because anything more complex than this would have taken a lot of time to run. So I basically defined RGB values for 4 colors, as you can see. Don't ask me what the colors were, I have no idea now. But they are 4 colors. Now, the idea is to then define a threshold. A threshold is basically a number. It's a number that denotes what the minimum distance might be between 2 different points. So a threshold is basically, you can think of it as the factor of the measure of the relationship between 2 points. And this threshold, this particular number is really, really important, because that helps the algorithm rather figure out what's going on in your data. And then all you have to do is call the clusterfuck library's function, pass it the data, pass it a dictionary with your data, tell the library what your threshold is, and it runs. So let's run it. Can everybody see that? At the bottom. So essentially what it has done is it's run a hierarchical cluster. Hierarchical clusters are a different method of clustering where you define hierarchies of different colors. Different data sets. It works really well for colors because how do you get different colors? You get them by mixing different values of red, green, and blue. So theoretically, every single color is a child. It's a product of those colors, and this is where hierarchical clustering is really, really useful, because it allows the algorithm to fix up your data in a way that's easy for you to understand. And that is what I've essentially done. That I gave it the values and it tried to cluster them based on which color comes under which parent color, which is red, green, and blue. Very basic example, like I said, there's not a lot of time, so I leave it to you to play with. Lots of interesting applications. Yes. No, unfortunately. Okay, so did everybody hear the question? Okay, so basically Zafar asked if it uses SVMs. Support vector machines, very, very, very powerful tool in machine learning and deep learning as well. Unfortunately, no, this particular library does not support SVMs. And the worst news is that no JavaScript library right now supports SVMs. But I have good news for you too, so just hang in there. And let's check out brain.js, because I really love brain.js. It's one of the best libraries out there for neural networks, and that's saying a lot because you've got some really good neural network libraries in Python and Julia. But this takes the cake. Alright, so again, neural networks are really useful for image analysis. I basically took the same example that I wrote for clusterfuck and modified it for brains. Essentially what this particular code is trying to do, or at least what I think it's trying to do, is trying to teach Node or the computer, take your pick, how different contrasts match up to different parent colors. Again, contrast is a very, it depends on the parent colors as well. So depending on what your RGB values are or what your hex values are, color contrast shall differ. So one of the applications of neural networks is to teach them how to identify different color contrasts based on what colors you give them. And this is what the code tries to do. Unfortunately, one of the problems with brain.js is that its output is not very human-friendly. Unlike Python, SciPy. SciPy, when you call a particular neural network using SciPy and a couple of other, there's something called Theano, which is great neural networks. They give you to create distributions, which is really easy to understand. You know, probability Gaussian distributions. Unfortunately, Brain.js is not yet at that level, so you would have to then write in a bit of plugin code, maybe hook it up with D3 or your favorite graphing library to make sense of the data. So it does something. I have no idea what it does because, like I said, there is no understanding what it's trying to tell you without actually being able to graph it. But the essence is, based on the colors that I gave it, it tried to compute what the black and white values were for their color contrasts. And I think it did a pretty good job because when I tried to verify those results using Photoshop, the values were quite similar. But of course, JavaScript is going to give you much more precise values, which Photoshop won't. So you could technically use libraries like this in your JavaScript, in your front-end JavaScript pipeline to automatically calculate color contrasts and, of course, enhance the UX of your particular app. Right. So now we are done with this particular demo, and now let's come back to what Zafar mentioned: SVMs. Just a small thing. So I think we can all agree upon the fact that there's not a huge ecosystem around JavaScript for this sort of computing. So what would you do? Like, I ask you, what would you do in such a scenario? Let's say you were hell-bent on using JavaScript for this. What would you do? Anybody? Come on, don't be shy. Cliche remark. Just think, out of the top of your head, the first. Okay, I think that's possible if you're Tony Stark, but yeah. That's of course an option. But a lot of times, we really don't have that option. I mean, we've got something to do. We've got a particular problem to solve, and implementing our own library would be a bit of a, it would be overkill. What, any other takes on this particular matter? Okay, so how many of you have heard of something called stupid question, Mscript 10? How many of you have heard of it? Nobody? Nobody's heard of Mscript 10? Okay, ASM.js. So yeah, so ASM.js is basically about running JavaScript at near native speeds inside your browsers and also on the servers. Mscript 10 happens to be Mozilla's interpretation and implementation of the ASM.js interface. Basically what I'm trying to tell you is you can compile existing C and C++ modules and libraries into JavaScript and reuse them wherever you want to. How does that sound? Now, having said this, can anybody now tell me what kind of approach you would now take if you wanted to build an ecosystem around JavaScript for technical computing? I'm sorry. There you go. If I had something, chocolates, I would have bought okay, sorry. Next time. Exactly. You could build a wrapper. You could technically compile existing C, C++ based libraries, and I'm saying C, C++ based because that's what Mscript 10 does. A lot of Python libraries can be compiled using Cython. Cython's this implementation of Python where you speed it up using C and you get C-based libraries. Recompile them into JavaScript and you're done. Essentially what you've now done is retooled another ecosystem for JavaScript. You can now use it on Node, you can use it in the browser, although I wouldn't recommend that again. And you could use it on embedded hardware such as Raspberry Pis, BeagleBones, drones, and we'll come to that in a bit. So as an experiment, so I'll be speaking at the Bangalore event as well, and to experiment with this, I compiled this library called Eigen. It's a really nifty linear algebra library written using C++. Basically compiled it using Mscript 10. And I wrote a basic script in C++, which can then be compiled into JavaScript and used throughout. So let's jump into that. It's almost embarrassing, my experience of MacBooks. So a bit of, a couple of words on MScript-10. MScript-10's architecture is based on top of the low-level virtual machine, LLVM. The approach that they've used is to compile C and C++, any of the two, into LLVM bit code, which is then compiled using the EMCC compiler, which they provide, into JavaScript. It's pretty fast because of the fact that it's LLVM, so heavily optimized. Unfortunately, if you're trying to build, so using MScript-10 is not that easy. You have to, compiling it for your machine does take hours. So this is a 16 GB cluster running on rack space, and it took around 7 hours on this to compile. So you can imagine how heavy this stuff is. But once you're done, it's amazing. It's blazingly fast. So let's check it out. Right, so I'll quickly show you the very basic code that I wrote using C++. Really simple. All it does is create two matrices in the runtime, assign a couple of values to them, try and add them, display the try and add particular elements in them, and then display the results. Really, really basic. So let's why don't I compile it right here for you? Just a second. Actually, that's going to take time. Let me just show you the compiled code that I came up with. Bear with me. This is going to be fun. So once you compile your C++ code with EMCC, what it essentially gives you is a JavaScript file. Again, you can run it using Node right then and there. You can access it in a browser, so you can just append it to your HTML and play with it. Let me show you the code. That was fast. So that is essentially what MScript-10 does. It statically links your entire. So like I mentioned, I referenced the icon library. What it essentially did was take the icon library, compile the whole thing into JavaScript, and then plug in the small program that I wrote, and then present it as a file. So not only can you run your program, you can then just use that particular file and run anything else too. So now let's run that. If I just do node a.out.js, it seems to work. I didn't manually verify that. I trusted MScript-10 to do its job, but it works. Now, all this while, you might recollect that I've been saying I don't recommend using this in a browser. Can anyone tell me why?
Large output, large JS files that MScript-10 compiles, like very verbose for, is that the reason?
Very verbose, yes, that's one. Like I mentioned, I get the entire library has been pre-compiled into JavaScript and just plunked in there. Imagine doing this on Google Chrome. I tried it, and yeah, let's just say I had to reinstall Google Chrome after that. Seriously, yeah. But the funny part is, so a friend of mine tried it on Safari and it worked, and that's really surprising because Safari is supposed to be a memory sinkhole, right? But they seem to get it seemed to work on Safari. One of the disadvantages of this particular approach is the fact that because your entire library has been statically compiled and linked to it, a normal browser cannot take the load. I mean, the JavaScript will never load, your browser will end up crashing. It will be the equivalent of opening 60 tabs on your browser, maybe worse. So that is one disadvantage. But having said that, oh sorry.
Yeah, so did you try running that on Firefox? Because since it's compiled using MScript, it should have worked better on Firefox?
It should have, unfortunately it didn't. So
okay.
I tried it across 4 browsers, Firefox, actually 5. I tried it across Firefox, Tor's implementation of Firefox, Chrome 26 point something, and Safari. It worked in Safari, which is really surprising. Chrome crashed, Firefox hung. It didn't exactly crash, and once I managed to shut down the process, it was fine after that. And Internet Explorer, let's not go ahead. We all know what was to happen.
But they were able to run Doom, by the way, using
They were able to
MScript.
run Doom. So I believe it also depends a lot on the library that you're making.
Yeah.
Doom must have been heavily optimized. Eigen, I doubt. I mean, I don't think it would have been optimized to that extent because Eigen's essentially an academic project. Doom, I believe, is commercial to some extent.
I'm not sure, but I just know that Doom was made available in the browser because with using Mscript.
Yeah, and the other part to it is so Mscript itself is as extensive as the GCC compiler suite. So as you know, GCC has a lot of different switches for optimizing your code, and Mscript tries to implement at least 97% of those optimization methods. So if you play around, like if you have the time to play around, which will take weeks, then yes, you can actually come up with a really optimized and minified JavaScript source that you can then plug into a browser and hopefully it will not crash. Might be a little sluggish, but it won't crash. So that concludes the demos, and now let's just do a bit of what Einstein used to call thought experiments. Alright, so like I said, we're able to do this. There are so many libraries out there that are just waiting for you to go into them and compile them. Intel comes out with something called the MKL, the math kernel libraries. So they are amazingly, blazingly fast and amazingly documented and really feature-rich as well. You compile them for JavaScript, then you've got an entire. You don't even need Python. You don't need anything after that. All you need is Google Chrome and maybe a node installation. And similarly, there are a lot of interfaces between C++ and R. There are a lot of interfaces between there's Python for Python. So, like I said, a lot of libraries that you can recompile and retool for your benefit. Apart from writing your own, which I would love to do, by the way. By the way, we're accepting donations to write a whole ecosystem for JavaScript. We accept Bitcoins, Terracoins, Litecoins, and of course, plain old dollars. Right. So, where can we go from here? So one approach that came to my mind was restifying your mathematical models. You've got great web-based frameworks for Node.js. There's Express, there's Sales, there's what's that new one called? I forget the name. There's one that I've been working on called Berliner, which is written in CoffeeScript. So there are a lot of different frameworks that can easily allow you to spin up quick APIs. Imagine writing very generic machine learning or neural network models, and then just exporting their functionality using Express. Create a quick API. The user hits a route, maybe gives a post request with the data set, and Node does the magic, probably gives back a D3 enabled visualization. Which brings me to the second point, D3.js. I don't need to say it, but I'll still state the obvious because I love doing that. D3 is by far the best visualization package out there. Even if you take matplotlib into account. Imagine plugging in D3 with the libraries that I've mentioned and with the other libraries that already exist. WebGL, so Zafar had mentioned, animation. You have models running at the back end calculating every aspect of your scene. So I'm not an animation expert, but I believe that there are tons of calculations that go into rendering a particular scene. You've got JavaScript and you've got WebGL. What else do you need? And now let's come to two very how should I put it, controversial items. NaCl. How many of you are familiar with NaCl? Super. Oh, that's Manish. Hey, what's up? So NaCl, Google's native runtime. Google's effort to port a lot of existing Intel architecture-based libraries, a lot of Intel architecture-based code onto the browser. Essentially, it means that you can run a subset of the x86 assembly language in your browser. A lot of different tools have been already ported to NaCl. A very basic subset of Python, and IPython has also been ported there. So it's like running Python in the browser. Mscript 10 did it too, but this is rather different. So again, a lot of your if you write JavaScript code which then talks to very basic math libraries that have been retooled to run inside your browser using the native client runtime, that's amazing because the native client runtime guarantees a fair degree of performance. And now we come to Cylon.js. Anybody's familiar with Cylon? So this is, if you're into robotics or hardware or embedded stuff, Cylon is a godsend for you. Essentially, the premise is simple. One language to rule them all, which is JavaScript, which can run on multiple devices. They support a lot. Raspberry Pis, BeagleBones. They support a lot of those new Philips-based home automation devices, bulbs and stuff. They also support parrot drones, which is my personal favorite. Imagine having a drone which has a neural network running inside of it, written in JavaScript, which, being a high-level language, means it's really easy to write a neural network. Now imagine the neural network can identify your enemies and just pepper spray them. That's a sample, scenario. But again, there are a lot of applications. The drones can use neural networks to recognize landmarks. Maybe just go to a restaurant and tell you if it's crowded, or go to a particular landmark and tell you what's going on over there. A lot of different applications. You could technically control your entire home using JavaScript because a lot of Philips' home automation gear supports Cylon, rather the other way around. Cylon supports the Philips automation gear. So technically, we're covering 3 different platforms: the server, the client, and the robot. What do you guys think? Does that sound interesting? I think it does. Maybe this is the beginning of Skynet, so to speak. Maybe this is the beginning of really intelligent machines that can think for themselves and maybe add value to our existence on a whole. So anyway, I think that should be the last slide. Actually, that is the last slide.
So yeah, we have like 2 minutes for questions. Otherwise, you can always catch Rudi around here.
Yeah.
He is gonna be here.
Absolutely. I'm sorry, I didn't catch the last part. Okay, so first, I speak from a very personal perspective. I don't see the harm looking at the fact that, like I mentioned earlier, unlike a lot of other languages that I've worked with for math and science, JavaScript straddles 2 seemingly disparate worlds really perfectly: objects and functions. Unlike Python, unlike Julia, unlike R, JavaScript really does that really well. Now, if you look at JavaScript as a standalone language for mathematical computing, yes, the idea does seem a little far-fetched. But then, like I said, if you look at the previous slide, which is this one. Now, when you look at the broader picture, the bigger picture, when you look at the fact that, you can actually, you guys are web, that's the point that I'm trying to drive at. You guys are web programmers. You don't need to learn esoteric languages anymore to do scientific computing. You can already play with what you can already run with what you know. It's a lot like PhoneGap. The whole premise around PhoneGap was that you can easily target any mobile platform out there if you're just a web developer. So I'm not saying this is as close to PhoneGap yet, no way. It's going to take at least a couple of years to get there. But it's getting there. It's got the potential to get there. And personally, I really hope it gets there because I love JavaScript. Now I've started to love it. And yeah, I hope that answers your question. Anybody else?
One last question.
Super, I think that does it. So feel free to hit me up for the GitHub repository. I forgot to add it here, my apologies. But feel free to contact me for the GitHub repos and stuff. And I hope somebody takes this forward. Thanks a lot. Thank you.